My name is Jesslyn Dace. I am a master's student in the Department of Mathematics and Statistics, and I worked with Dr. Shapla on this statistical analysis. We studied the multivariate analysis of body fat percentage in adult males. The data that we had to work with came from Dr. Fisher, who is a professor at Brigham Young University, and the data set contained records for 252 adult males. And for this study, we considered 15 of the variables. For our response variables, we used two different ways of calculating body fat percentage, one using Rose-X equation and the other using series equation. Both of those equations use density, and so it requires the subject to be placed underwater and calculations are weighed that way. This is a very costly procedure to implement. And then using our predictor variables, we have age, which is in years, weight, which is in pounds, height, and then we have 10 body circumference measurements for various parts of the body. And we would like to see if we can use those predictor variables to predict the body fat percentage in a less costly way than full body submersion. The objective of our study is to examine any relation between the response variables and the predictor variables. So those ones that use total body submersion, and then the ones that are more easily measurable, like height, weight, age, and the body circumference measurements. And then we want to see if there is a relationship, if we can determine a smaller set of variables or groups of variables that can be used in place of the entire set. And then we can find a linear combination of these predictors, which can summarize the variation in the total data. Our analysis includes multivariate regression, factor analysis, and principal component analysis to accomplish the objectives of this study, to see if we can find a less costly method of estimating body fat percentage in adult males. So we started with multivariate multiple regression, and this was to see if there was even a correlation between our response variables and our predictor variables, to see if we could use things like age, weight, height, and the body circumference measurements in place of the more costly submersion estimates. And for these, we had our two response variables. We had 13 predictor variables and 252 observations, and the Wilks lambda value ended up being about 0.23, and the critical value was about 0.86. So the lambda value is much lower than the critical value. Since the Wilks lambda value is less than the critical value, then we can say that there is a relationship between those response variables and the predictor variables. So there is a relationship between age, weight, height, and the body's circumference measurements and those body fat percentages calculated through density. So we can use the other methods of measurements to predict what the body fat percentage will be. Since we did find that there was a correlation between the measurements and the body fat percentage, we wanted to see if we could narrow down the variables that we needed. So we did a factor analysis and looked at the correlations between the different measurements. And the correlation matrix showed that weight and then the 10 body circumference measurements, they're highly correlated among themselves. So the body circumference measurements and weight gave similar information to our analysis. And then age and height had weak correlations with all the other ones, so they were very different from the weight and the body circumference measurements, and they were also very different from each other. So just from looking at the correlations, we kind of have a guess that we might need 3 factors to explain this, and we can look at a scree plot, which shows different principal components and which ones we'd like to keep. And the scree plot, it shows us, if we look at the dotted line on the top, that about 80% of our variation is explained by 3 factors. So we know that we want to keep 3 factors when we do our principal component analysis. This table shows the specific values for the factors that we chose to keep in our final analysis. You can see that first factor includes weight and then all the other measurements, since they were highly correlated among themselves. Those are all explained in factor 1, whereas factor 2 just includes age by itself, and factor 3 includes height by itself. And so those are the 3 factors that we can use, and so instead of having 13 variables in a final predicting equation, we would just have these 3 factors that we can use in place of the 13 original entries. So in conclusion, we did find that body fat percentage for adult males can be reasonably estimated using just things like height, age, weight, and body circumference measurements. And this method explains a lot of the variation. If we use the factors and we keep the 3 factors, we're explaining about 80% of the variation in the data. And so this method is less costly than the total body submersion method used to take body density, used in those equations to measure body fat percentage. And so this, when the body fat measurement does not need to be extremely precise, could be a good method to use instead. Thank you.